All right, welcome back. We're gonna finish the chapter with this little lecture video right here. We're gonna start out with some policy applications, what we've been talking about. So the first one is a section that's trying to estimate the statistical value of a human life. So how much is a life worth? The line that connects the combination of wages and risks that we talked about in the previous slide from the last video. So I'll go back here. This line right here is the hedonic wage function. So it kind of brings together the the more, or I guess less risk averse workers down to the more risk averse workers and the types of firms that they work at. By drawing a line between them, we can kind of estimate what the trade-off is. Well, some economists try to use the existence of that hedonic wage function, kind of estimating that line to try to estimate how much people value a human life, how much more money they're willing to spend to make them safer. So, yeah, if you're following along your textbook, you could look at table 5.1, and that shows the risk of a workplace injury across a lot of industries. And you see that there's wide variation between them. Some are exceedingly safe, while others are relatively quite deadly, and probably much more deadly than you or I would be willing to do for a career, especially for something over the long term. So models that explore the relationship between the wage and the probability of injury on the job find that a 0.001 increase in the probability of a fatal workplace injury increases wages by $8,700 a year. So let's look about how we can use that to understand how much people value safety. We can compare two firms to do this, and we'll make the math as simple as possible for us. So let's say one has the chance of death at P, while the other has the chance of death at P plus 0.001. Yeah, it makes the math easy. So they pay at the second company $8,700 more per year to each worker to account for that risk. If both firms hire 1,000 workers, this corresponds to one additional worker dying in the second firm, because the probability of a fatal injury is 0.001. Workers are willing to accept this risk because each one receives extra money to work for the riskier company, $8,700 each year. And let's face it, everyone assumes that if there's going to be a fatal injury or something bad that happens at work, it's not going to be them, it's going to be someone else. But now taking more money for a riskier job implies the opposite as well, that each worker at that first firm, the relatively more safe firm, will be willing to give up $8,700 to reduce the chance of death by 0.001. And because there are 1,000 workers at both firms, those 1,000 workers at the first firm are willing to give up a total of $8.7 million to save one human life. So we can use that as the estimate of value of human life and say that workers are willing to pay $8.7 million to save one life. Now, my dad worked for an insurance company. What he did was inspect businesses to ensure that they met reasonable safety standards to prevent injuries so that his company could minimize the workers' comp that they would have to pay out if there was an injury. So I've heard about OSHA for years. OSHA is the Occupational Safety and Health Administration. They were created back in 1970 to ensure the safety of workers, especially in industries like manufacturing and resource extraction, ones that can be quite deadly, but their standards apply to all industries. And their working standards range from basic protections like requiring hard hats in constructions to more stringent requirements like advanced safety protocols in manufacturing. For firms, complying with OSHA safety standards often requires an investment in safety equipment, training, and other measures, all of which affect their cost, adding a bunch of cost to their actual production process, and by extension, affecting their profits. On the flip side, workers typically prefer jobs that offer higher safety standards because these reduce the risk of injury or illness or even death. But if we discussed, workers also care about wages. So how do firms balance the cost of meeting safety regulations while also keeping their wages competitive? And how do workers' preferences for safer jobs interact with their wage demands? We can use the model of isoprofit curves and individuals' utility functions to see how firms respond to safety regulations like those set by OSHA, how this impacts their profits, and look at the worker choice side. So here, this graph illustrates the impact of these workers, the safety regulations from OSHA for workers. Prior to the implementation of an OSHA regulation, the equilibrium point was at point P, right here. So the wage, the equilibrium wage is wage star, and the probability of injury is here at rho star. That's the Greek letter rho that kind of looks like a P. So what happens if OSHA sets a safety standard that is safer than the previous acceptable level? Let's say they set it at this point rho bar, where you cannot go beyond this to the right to any higher probability of injury on the job. This will end up shifting the firm out to a higher isoprofit curve. So initially we're on this isoprofit curve at pi star. But to get to this point here, they end up being at this higher one at pi bar. That represents a lower profit level. Remember, the farther we get out, the higher we get up, the lower the profit is for the firm. So it's going to add cost to the firm to try to meet that standard. It's going to reduce their profit level. The hedonic wage function right here, this line, represents the trade-off between wages and safety that each worker faces and what they're willing to do. So we can move down this curve until we reach point Q here, which is right at the new safety standard. What do we see as the result? Basically, the risk of injury is lower. It used to be up here, now it's down here. But the wage is also lower. The equilibrium wage used to be up here. Now, because of that trade-off between the willingness to accept safety or risk and wages, is now pushing the wage down here to this lower level. Firms no longer need to compensate workers for the risk up here because the risk is down here. So again, it's that lower wage. In effect, it's now illegal to accept the job represented in point P, that initial job that we were looking at. The firm is also less profitable because of the cost of reaching those safety standards. In an industry with a tight profit margin, or if the safety standards are particularly costly to meet, this can push a firm to a point where they're forced to cease operations. In other cases, it may be relatively cheap for the firm to get down to that point, and the reduction in wages will be small and it'll have a small overall effect on the firm. What it depends on the type of industry that the firm is operating in and the type of safety standard they're actually implementing, how expensive that would be. Now, that previous example assumes that workers accurately perceive the risks that they face on the job site. But anyone in 1950, if you would ask them about mesothelioma, you would just get blank stares. There were a lot of things like asbestos that we did not know were bad for us. And I'm sure there are chemicals today that workers work with in their daily job that we don't know are bad for them yet. Additionally, workers can misperceive risks. The simplest example is looking at a risky job and thinking, I know what I'm doing. Unlike those other guys who don't pay enough attention or show up on no sleep and try to operate heavy machinery, I'm not going to hurt myself like they do. I know what I'm doing. So where a regulator like OSHA really shines is finding places where workers misperceive the risk. They think they're safer than they really are, and regulate those areas to bring the market in line to what we would expect if workers had full knowledge of risk. A lot of times when we see regulations, and we'll talk about probably a few more in this course, where if workers had full knowledge, of course, we wouldn't need the regulation. But because they misperceive, they don't exactly understand what's going on, or they don't realize that the risk or whatever negative thing is higher is more likely, by stepping in, regulators can act as if they're revealing information and push us towards what we'd have if people had full knowledge. So let's look at the hedonic wage function in this graph. The worker is receiving wage W star, this equilibrium wage. Now, they think their risk level is at rho 0. They think they're on this utility curve, and the probability of injury is low. But in fact, in this case, they're wrong. The risk of injury is much higher at rho star here. So that's as if they're all the way out here on the utility curve U star. Because they think they're here, this seems to be a great wage for them, more than they require to work for this job. But because they're wrong about risk and the risk is actually higher, the government can end up helping them by imposing some safety standard. Let's say that they set the maximum acceptable risk at rho bar right here. It is higher, so it's Yeah, higher than they thought that they had, but much lower than the risk they actually faced. Their wage would end up declining. You look at where this utility function crosses the hedonic wage function at this safety level right here. That's going to be that corresponds to a lower wage than wage star that they were receiving before. But their probability of injury is much lower, much closer to what they thought they were at and what they were willing to work for. So when we think about what makes a job attractive, it's not just about the paycheck. Of course, that's important, but there's a lot of other factors that we consider when choosing a job. Things like the flexibility of the schedule, job security, and working conditions. These non-monetary job characteristics, what we call amenities, can play a big role in a person's job satisfaction. But here's the key. Jobs that offer better amenities, more vacation time, safer working conditions, often come with lower wages, while jobs with fewer of those perks often have to pay more to attract workers. This is part of what we call compensating differentials. Wages adjust to account for the desirability or undesirability about job characteristics. Initially, we just focused on safety, and part of that is because that's the most striking and simplest example. But we can also look at the other characteristics of these jobs to see the same trade-off in action. So for example, a job that requires long hours and unpredictable layoffs where you could get fired at any time without, much warning or expectation, the odds are they will need to pay more to attract workers compared to ones that have regular hours and better job security. Interestingly, we often assume these trade-offs exist. However, the evidence is fairly mixed, except in cases where the risk of death is involved. High-risk jobs do tend to pay more, but for other job amenities, the wage differences aren't always so clear-cut. So how do things like job security, work hours, or safety factor into wage differences? And I'm talking more general safety than, of course, the actual death. Some of the problem is that it's difficult to actually account for and isolate just one of these characteristics. So any study that is trying to estimate those has a really difficult time holding everything else constant and focusing on just that one little difference. And I think that's the biggest problem for being unable to estimate these amenities. I just want to highlight this again, that it should come as no surprise that jobs with good characteristics offer lower wages than those with worse characteristics. So for a place with 3 shifts, if you're looking at like manufacturing, the night shift often pays better than the day shift. I worked a job that had all 3 shifts. It actually wasn't in a factory, it was somewhere else. And I typically worked second shift, which wasn't bad. It wasn't as good as day shift, but it was still pretty good. But I would also pick up third shifts every now and then if I had, nothing going on, because I could make a lot more money for just picking up those extra 8 hours. It takes a lot more to get people to work third shift, so they end up paying more money. On the other hand, people complain all the time about low wages in academia. New positions are often non-tenure track, which is an amenity that a lot of people appreciate in academia. And they often pay very low, like $50,000 per year, and there's almost no job security. But the reason they do that is academia is a great lifestyle for so many. So the wages often reflect that. And because so many people would like to work in that environment, they're able to offer low wages. Now let's look at one specific example. A textbook goes through the probability or likelihood of layoffs and how that affects compensating differentials. So we use unemployment insurance. This is through a government program to protect workers from the risk of layoffs. But you could ask, what if layoffs are priced into workers' wages? It should be obvious to workers that in some high-risk industries that have a lot of turnover, that the risk would be priced in, that it's something that they can anticipate ahead of time. Unlike some industries where I'm sure it is more likely for people to get laid off, but it's not expected. Workers don't see that difference ahead of time. So we can use the standard neoclassical labor-leisure model from earlier in the course and use it to compare 2 jobs, one which is regular year-round and one that's a seasonal job. So point P represents the point for for the full-time year-round job. So at this point, they have a leisure L0, which corresponds to H0 hours of work. Point Q here represents the part-time job. Has L1, so more hours of leisure, which corresponds to H1 or fewer hours of work. Again, because they're only working for a part of the year. If that firm tried to pay the same wage for the part-time seasonal workers and for the full-time year-round workers, what we would see is that no one would want to take the seasonal job. This utility curve down here, remember for the workers' labor, leisure, supply model, the closer you get to the origin, the lower utility you have. So this is a much lower level of utility than point P up here. So given the choice between the two, no worker would choose this. They would choose point P. Or some will have extenuating circumstances. Maybe they got fired right for the holidays or something like that. But in general, given the choice between the two, they're going to choose point P. So how could a firm get a worker to work seasonally? Thing they would have to do is increase the wages. So originally, they're both making the same wage. If we increase the wage to W1, so now we have a steeper wage curve. If you increase the wage, the hourly wage high enough, you could get up to point R here, which matches the same amount of leisure and hours worked throughout the year. So you have that same seasonal job. It's now paying a higher wage. Annually, you're still making less money, but their hourly wages are going to be much higher than before. And that's how you can get some people to work seasonally. At point R, the worker is going to be indifferent between the two jobs because they're both on the same utility curve. Now, this can also apply to jobs like construction, where you can't work year-round, at least in places like West Virginia or Pennsylvania, or jobs with a high chance of being laid off. It takes much higher wages to attract people to these jobs, especially when you're either guaranteed or very, very likely to be out of a job for at least some of the year. All right, so let's end the chapter by looking through one final amenity, in this case, health insurance. Thanks to wage controls in World War II, some firms began offering health insurance as a way to attract more workers because they couldn't pay them anymore. Flash forward 100 years, and instead of buying health insurance on our own at adulthood, now we all get it through work. So let's assume that workers have a positive value of employee-provided health insurance. So it's a normal good. Basically, that means more of a good of health insurance is preferable to less health insurance, all else being equal. So at the same cost and everything. The workers' indifference curves for wages and health insurance are downward sloping and convex. So worker A does not value the health insurance as much, so it's a lot more shallow here. Whereas they would be willing to take large reductions in their benefit of their coverage in order to get a small gain in their wages. So moving from, say, here on the utility curve, they're down here on their health benefits. They move all the way over to P. They're increasing their wages by just a little bit, but decreasing their health benefits by a lot. So they don't really care much about health benefits or health insurance. They're probably a single, healthy young guy. I really didn't care about health insurance when I started working. Meanwhile, worker B has a steeper indifference curve. So this shows that they value health insurance relatively more. In order to give up some of their health benefits, they're going to have to receive much higher wages compared to that first worker, worker A. So workers A and B can choose a position along the same isoprofit line from the firm. Worker A is going to choose the tangent point to their indifference curve, which is point P up here. So they'll choose no health benefits and the highest wage they can possibly get. Whereas worker B values health benefits much more. So what they're going to do is choose here, point Q, where they have some level of health benefits and a lower wage than worker A. In order for the firm to offer a better combination of wages and health insurance benefits, the firm would have to move out to this farther out isoprofit curve. So that represents lower profit for them. Again, because it costs money to provide these health benefits. Research doesn't really find this relationship holding, which your textbook talks about at the end and goes through why this might be the case. I think this is pretty interesting. And one thing that they mention is very likely the culprit. At this point, the workers that choose no health insurance are somewhat different than the workers that choose health insurance because so many workers choose. So they differ in key characteristics from those who choose health insurance. Maybe they're risk loving or they go after jobs with atypical payment schemes. There's something about them that's different. So it makes it very difficult to compare the workers that choose to go without health insurance versus the ones that do go for health insurance. And your textbook goes into several other possible explanations for that. All right, I'm running long, and with this, we will end the discussion for chapter 5 about compensating differentials.